Before even thinking about engaging the dynamic positioning system, a thorough series of pre-setup checks is absolutely mandatory. This foundational phase ensures the vessel has the necessary power and propulsion to operate safely. The first step is to verify the status of the vessel's power plant. Operators must confirm that the required number of generators are online and synchronized, providing sufficient power to handle the expected operational loads. This includes not just the thrusters but all ancillary equipment. With the power plant configured, the focus shifts to the thrusters and propulsion units. Each thruster, whether it is a tunnel thruster, an azimuth thruster or a main propeller, must be checked for availability and readiness. This involves confirming that they are started and clutched in and responsive to commands from the bridge. Another critical component to inspect is the uninterruptible power supply for the DP control system itself. This ensures that in the event of a momentary blackout or a problem with the main power distribution, the control system remains active and aware. Finally, operators must verify the redundancy settings and DP alert modes. For a DP2 operation, the system must be configured to be fault-tolerant. The operator must check that the bus tie breaker is open and that audible and visual DP alarms are functioning correctly. Once the vessel's power and propulsion systems are confirmed to be ready, the next step is to establish a reliable and accurate sense of position and orientation. This is achieved by setting up and verifying the navigation and reference systems. The foundation of the vessel's heading information comes from the gyro compasses. For a DP2 vessel, at least 2, and often 3 independent gyro compasses are required. The operator must select multiple gyros within the DP system and closely monitor their readings. Any significant deviation will trigger an alarm. Next, environmental sensors must be activated and checked. Wind sensors, also called anemometers, must be installed so they avoid turbulence, and at least 2 should be used. Motion reference units measure roll, pitch and heave. MRU data lets the DP system separate wave-induced motion from true position change. The most critical components for maintaining position are the position reference systems. A DP2 vessel must use at least 3 independent PRS of at least 2 different types. Common systems include differential GNSS, laser-based systems like fan beam or Cyscan, and acoustic systems like HiPAP. The operator must power up each PRS, ensure it is tracking its target, and verify stable, accurate output. Check signal quality, data latency, and integrate the reference systems into the DP control system. The operator selects which PRS to use for position calculation. The DP system combines the inputs by weighting and filtering to produce a single, reliable, best-fit position. Noisy or erratic systems get less weight or are rejected. With power established and reference systems online, the operator can now focus on configuring the brains of the vessel, the DP control system itself. The first action is to initialize the DP control computers. On a DP2 vessel, there are typically 2 identical computers or 3 running in parallel. The operator must ensure all computers are powered up, synchronized, and free of any hardware or software alarms. This redundancy ensures that if one computer fails, another can seamlessly take over control without interruption to station keeping. Next, the operator must load or confirm the vessel's mathematical model. This model predicts how the vessel will react to forces from the thrusters and the environment. The operator needs to check that the correct model is loaded for the vessel's current draft and trim. Parameters may be entered manually or fed automatically from sensors, but must always be verified. After loading the model, the operator sets control gains and operational limits. Gains determine how aggressively the DP system reacts to position deviations. Limits for maximum position excursion and heading deviation are set, which will trigger alarms if exceeded, providing an essential layer of operational safety monitoring. Finally, the operator must set up the consequence analysis function. The consequence analysis continuously runs in the background, simulating the effect of the worst-case single failure and predicting whether the vessel can maintain its position. The operator must ensure this feature is active and review its predictions. If the analysis shows the vessel would drift after a single failure, the operation is not safe to proceed. Before committing the vessel to a critical task, a series of final tests must be performed to physically validate that the entire DP system is functioning as expected. These are often called field arrival trials, or DP trials. They serve as the final gate check for operational readiness. The first and most fundamental test is the thruster response check. With the vessel in a safe location, clear of any obstructions, the operator takes manual control of each thruster individually, and will command a specific amount of thrust, for example, 20% ahead, 20% astern, and verify that the thruster responds quickly and delivers the commanded output. Following the individual thruster checks, a full system function test is conducted. Pure surge, sway, and yaw while the operator watches thruster allocation logic. The operator checks thrusters work harmoniously and that the vessel model is accurate. Testing PRS may involve deselecting DGNSS and reselecting, testing laser lock-on to a reflector, or briefly blocking and unblocking sensors to ensure reacquisition. Each PRS must prove reliability. The final trial is a short-term station keeping test. Engage auto position and observe position keeping for 15-30 minutes, shortened for trial, while monitoring position deviation and thruster power. This confirms power, propulsion, sensors and controls are working together as an integrated system to safely hold position. The process of engaging the DP system to achieve a stable automatic hold is a deliberate and methodical sequence of actions. It begins with maneuvering the vessel manually towards the target location. The operator uses the joystick controls for surge, sway, and yaw. During this approach, the operator must maintain situational awareness, speed, proximity to installation and subsea assets, and environmental conditions. As the vessel nears its final working position, typically within 10 to 20 meters, the operator prepares to transition from manual control to automatic assistance. The next mode to engage is auto heading. In this mode, the operator continues fore, aft, and lateral control while DP maintains heading. The operator ensures the selected gyro compasses are stable and the desired heading is set so the system can counteract yawing forces. By pressing the auto position button, the operator hands over surge, sway, and yaw control to the DP system, which will use all available thrusters and reference systems to maintain location and heading. The operator must closely watch the system's initial response to ensure a smooth transition. Thruster activity should increase, then settle as the system builds a picture of environmental forces. Immediately confirm the vessel is holding within predefined limits, and review thruster usage to ensure it is reasonable for conditions. Once fully engaged in auto position, the operator's role transitions from active control to active monitoring. Vigilance remains essential throughout the operation. Once the vessel is securely holding its position in automatic DP mode, the operator's role becomes one of constant vigilance and active management of the system's redundancy. Continuously monitor position plot, PRS status, power plant loads, thruster performance, and environmental conditions to ensure capacity to respond. DP2 requires that no single fault should lead to total position loss. Systems are separated into at least 2 independent groups. The operator must ensure bus tie remains open. Thrusters and reference systems are logically distributed between redundant systems. Monitor the tiered DP alarms. Yellow advisories like a single PRS rejection need investigation. Red alarms like position dropout demand immediate action. The consequence analysis provides real-time assessment of the vessel's ability to withstand a failure. Monitor it continually. In the event of a system failure, assess the situation, inform relevant personnel, and determine the safest course of action. This could involve manual intervention using an independent joystick, or switching to a backup DP panel located at a different console. The most critical emergency action is the emergency disconnect system. If the vessel begins to drift uncontrollably, activating the EDS will terminate the operation and protect personnel and subsea equipment. Finally, every operator must be thoroughly familiar with emergency and backup systems through regular training and checklists to ensure personnel, environment, and the vessel remain protected. Setting up DP2 on OSV =sign power plant plus thrusters, plus reference systems plus DP computers plus FMEA redundancy plus continuous monitoring.